Good morning, everyone. We really appreciate you making time to attend today's seminar. And I'd like to thank GS1 especially for arranging this presentation. My name is Steve Schultz, and I'm the Operations Director at Retriever Communications. Also presenting today is Margot Hoekstra, who is our Senior Business Analyst. Just by way of background, Retriever is an Australian company that we specialise in enterprise mobility, and the company was founded in 1996. And to give you some perspective, that was 10 years before the first iPhone was released. All of our design, development and support is done here in Australia. And for over 20 years, we've been helping Australian businesses to replace manual field processes with effective mobile applications, often for mission critical processes, which requires them to work day in, day out. With our field mobility experience, we think some of our technology can really help companies wishing to adopt the GS1 standards. Today's presentation is titled How to Design and Deliver an Effective Mobile Asset Management Solution. And by this, we mean the application of mobile application technologies to assist in the maintenance and repair of assets, which are often dispersed over large distances. Now, we expect this presentation to take about 35 minutes, and we'll take questions at the end. And you should be able to raise questions as we go along through the Q&A button. Today, we'd like to discuss how the requirements of the assets need to be effectively linked to the human beings that need to perform the work. And that work might consist of inspections, taking measurements, performing repairs on the assets. In doing so, we'll take a look at the requirements of the people and often the contractors that need to perform the work, the human factor. We'll then examine the key design considerations for a solution and give you some ideas for project delivery and how to get started. We'd like to use a practical example of an asset management solution in the mining and resources sector. Whilst we've got a range of industries on this call today, we think the fundamental principles apply broadly to any organisation that has assets distributed over large distances. And with that, I'll hand over to Margot.
So as Steve mentioned, we start with the asset and asset groups. This photo shows a well pad that's located in Queensland. It's actually in the south west of Queensland. The well pad contains a wellhead, which is the component at the surface of an oil or gas well that pumps the oil or gas from the ground. The well pad has a lot of components. For example, the generator that we see here, and that contains other assets like the solar panel and the antenna on top. And next to the generator, we see a compressor, and that also contains different assets, for example, valves. And these assets and sub-assets need to be maintained, serviced and repaired. Each asset will have a specific recommended tasks. For example, checking the oil level, measuring voltages and pressures, or even a task to maintain the area so the asset remains accessible. The defined tasks could have different frequencies on when they need to happen. And these frequencies can be different within an asset. For example, a measurement might be a weekly task, whereas a check to see if the same asset runs smoothly might be a daily task. That means that the worker who maintains these assets can have different asset tasks per visit. When you deal with a lot of assets that are of the same type, but from a different brand, then other design considerations are probably needed. For example, in the project we did related to the photo on the slide, they had a lot of generators, but different models and brands. The task for the generator was quite similar. However, there were some small differences. For example, temperature was in Fahrenheit for a US generator, but Celsius for other generators. We created templates with tasks for generators, but also additional sub-templates that were based on the main template, but with small changes adjusted.
So it's good to understand the needs of the assets, but the tasks that are carried out to service these assets are undertaken by humans. So in delivering a mobile application, we really need to match the human requirements to the asset requirements, and that linkage is through the tasks that are actioned. So typically to do that, we need to group the tasks and work into logical sets. We need to decide the distribution and routing of the work, particularly if contractors are involved. Importantly, we need to ensure that safety obligations are also met. In this well pad example, it's potentially quite a dangerous site given that you could have odourless flammable gas pumped up from the ground. So safety is extremely important. We also need to ensure that the people carrying out the work can correctly identify the assets that they're working on. And finally, we need to provide some sort of consistency of process across all users in order to get a level of quality.
The work distribution is dependent on the workforce. This workforce may consist of different specialty roles. For example, qualified electricians or diesel mechanics. And these resources are typically grouped in regions or branches. These workers may need to carry out different types of jobs. For example, if they're attending a site to conduct a repair, and it makes sense to conduct preventative maintenance works whilst at the same location to avoid a separate visit. It may be the case that the work is outsourced to subcontractors, perhaps to cover regional requirements or to provide skill. And these resources may be spread out across different states, each with different regulation requirements. It's important to determine the best route to take the technician when visiting assets, but which they have to maintain. In this example, the base is the triangle in the north, miles. When the field workers start their day, then the application should be able to show the field worker which side is next to go, so traffic times are reduced as much as possible. Of course, the task and work should be grouped into logical sets to maximize the efficiency of the visits, and so that while at the site, preventative maintenance tasks can be performed without the need for another visit. When the field worker arrives on site or the asset, then we need to ensure the safety obligations are met. The safety obligations are quite often done using paper forms like the one here on the left. This one actually shows a risk matrix where the field worker can determine risk and the measurement to reduce the risks. But it's much better to transform this paper form in an electronic form like the one here on the right. It is important that the information about the risk matrix can be included to make sure that the field worker does not need additional documentation in paper form. And by presenting a customized safety form to the technician, which needs to be completed prior to the work to start, safety obligations can be guaranteed. However, the type of job may have consequences to what needs to be filled out. It could even mean that a safety form is different depending if the job is a repair or a maintenance job. And the mobile application should be able to provide this. When the field worker starts to work, then we need to ensure that the correct assets are identified and serviced. This can be achieved by using barcodes and scan them with the device in the field. And on the video, that could be even like a smartphone, like the Samsung. Barcodes and mobile applications are perfect together as they complement each other. The placement and location of the barcode is important. The user should be able to easily scan the barcode without any issues. The barcode can contain just the unique identifier of the asset, but can contain more information about the asset, like the model and type. The application can provide more information to the field worker so they don't have a confirmation about the asset. They can change certain details about the asset, so the asset management system remains up to date with the condition in the field. The application workflow needs to fit the user's existing field processes. That is most efficient way and can ensure a consistent process that's followed by all users. The importance of this cannot be underestimated. For example, this screen might suit an office-based user, but would be extremely difficult for a field worker. When a screen like that shows on a mobile phone, for example, then the user needs to do a lot of horizontal and vertical scrolling to see all the information. Also, the field worker can choose and select the way they work with a screen like that, and therefore the workflow is not supported. This example is extreme, and most mobile extensions do not work like this anymore. However, a mobile extension can still be a mobile compatible version of the whole screen. These are the mobile-friendly versions of websites or website-based applications. It shows exactly the same content as the HTML pages. However, the information is presented more vertically to avoid horizontally scrolling. And although this method looks like it works, and in normal data websites it actually can, it's still not ideal for the field worker. In the example that we see here, the field worker is presented with a menu that they have to select first before doing the work. Some menu options like settings or specific office functions are irrelevant to the field worker. They will most likely select one of the menu options 95% of the time. And although it's just one tap on the screen, it gets annoying for the field worker to select the same option over and over again. The mobile application is most of the time not the core work task of a field worker. For example, if the field worker performs maintenance tasks on an asset or repairs the assets that the task, then that task is their main work. The mobile application is secondary to this task and will report on what the field worker has done during their main task. So the application should work in a way so that the field worker spends the minimal time on the device to record their work done. After all, they want to move onto another asset to main or repair, and the application is just administration. So the mobile application needs to act like a tool to the field worker and should adjust to the workflow to ensure most efficient way of capturing information. So in this example, we see a simple workflow as an example. The field worker has a job list, and after selecting the job list, they are presented with the safety form that we saw before. And after completing the safety form, the work can start. And the work can contain different things. In this case, it's like maintain the assets, parts, the time that it was taken, work recommended. And after all this work is done, then the job can be completed by asking for a signature from the customer. So if we go back to this main workflow that we discussed before, then we can also embed exceptions within the workflow. Let's say that part of the work, the field worker is performing maintenance task of assets. One of the tasks is a measurement of the temperature, but the temperature is outside the threshold, as we see here, and therefore this asset task fails. It is needed to repair the asset, and therefore a work order needs to be created. In this example, an extra button shows to start filling out a work order form, so this can be scheduled in for repair. So instead of showing the ability to create a work order in a menu, in this example, the ability to create the work shows when it's relevant and when it's needed. Another example following workflows are in forms. The digital form might be constructed differently from the paper form. The paper form is the end result of the task that needed to be done, often including signatures by the inspector or the customer, and these forms are used as legal documents. When digital forms are used, then the order of the input can be different from the output. For example, if the paper form contains a compliance page to be sent off to a governmental institution, then the information that shows on this form might have been collected earlier in the inspection than the place where the form is located. And quite often that is used as an appendix to the form. Or for example, a summary page at the start of the form contains information that is captured later in the workflow. While using the paper form, the inspector would just flip the paper pages forward and backwards. But it could be very tiresome on a device. The mobile application can present the best workflow for the inspector. However, the form is printed out or created as a PDF, then the order can be completely mixed up to suit the current form. So when designing the form, the workflow needs to be taken in account. For example, in this example, the first page of the electronic form was the part that was on page 2. You see that how is that the equipment, premises, and mobile unit is actually the part of page 2. And here it's the first page. Besides of the ability to follow the field worker processes, electronic forms have huge benefit over paper forms. For example, photos can be directly attached to the questions. And of course, the use of barcodes and capturing GPS coordinates is what can be used when completing an electronic form.
One of the problems with paper forms is the time it can take to get the data back into a system. Here's a real life example of someone out in the field. And you can see their digital dashboard there, the form sitting up as on their dashboard, blank forms and completed forms. And some of these could include safety forms. And it could be critical if an incident were to occur that that form is available and recorded somewhere. But as you can see, paper can blow out the window. And even when they get the paper form back to the depot, it could sit in someone's in tray for days before being processed. Using the electronic forms along with a mobile application means that this information can be available almost immediately. An electronic safety form in which a hazard is identified can advise the worker to immediately leave the site or to contact their supervisor for more information and prevent them from starting a potentially unsafe job. One of the byproducts of the immediacy of information is real-time visibility of what is currently happening in the field. And you can see on this screen here, this is an example of a scheduling application. And this would be used by office-based staff to assign work to workers. But it also shows them what's happening right now. Not only the status of a job, but as you can see, it also knows the location of workers, which has additional safety benefits if something goes wrong. The other thing is that if a job is going to take longer than expected, a supervisor has the ability to reassign the work to a different person to ensure that service levels are met. In order for decision makers to make the right decisions, it's important that they have access to accurate information. They need to rely on the fact that the data is complete, accurate, and consistent. However, often there's someone in the office that receives the information from the field worker, either paper or digital, perhaps through email, and then they may need to correct that information so it's in a reasonable state to go into the back-end system. They may even repurpose the data into a Word document like a service report to send to a customer as a record of the service. If you put in place the workflow and validation right at the point of entry with the field worker, you significantly improve the quality of the data. And this can take away the manual processes you can see in the middle. Ideally, there is no one in the middle. The information goes straight into the back-end system And when they complete their work, then all the follow-on processes associated with sending invoices and service reports is completely automatic. One of the benefits of the mobile technology is how it can enhance the traceability of the asset lifecycle. Not only is the recorded data recorded for every service, but you have associated data that helps to verify the auditability of that service. This includes the barcode verification of the asset, can include photographs as a record of what was done, and GPS coordinates and timestamps. And photographs can obviously assist the follow-on person that is carrying out work at that site. So it creates a record of history. And the really important thing here is that you then have a single point of reference, particularly if you engage people such as subcontractors, so that there is a clear history available for anyone that needs to perform service against these assets.
And it's important to design the solution to support different devices. Particularly if working with subcontractors, it's important to support a range of operating systems and device formats. For example, smartphones and tablets. These bring your own users need to be supported, and thought needs to be given to the distribution of the application. In the example given on the screen, it shows the same application used on the tablet and on the phone. The size is different, and therefore the layout of the application is different when using different devices. And this application that we're actually showing is an example of that asset tasking type of an application. And it's currently in use to maintain the previous shown photo of the well pad. And the application follows the workflow of the technician. It's currently in use to maintain the on the well pad. When they arrive on site, they perform the task in order of the sub assets within the well pad. Using the arrows on the left and right, or here on the left and right, the technician can navigate through all the tasks. What they also can do is just answering the questions or the things that they want to do, click on the thumbs up, and it then automatically goes to the next task. And in this case, that's an instrument reading that needs to be recorded.
Thanks, Margot. So different applications often need to be represented different ways. And it really depends on the requirement of the field worker. So if you look at the application on the left-hand side of the screen, this application was designed for a truck driver carrying out beer deliveries. And for that environment, for a device mounted on a dashboard, it's important that the amount of information presented to the user is very limited because they're focused on driving. And so this application is designed to just present what happens next and makes it very simple for the user to interact with the application. The application in the middle was an application built for a company that is an advertising organisation that installs posters into supermarkets and shopping malls. And you'll see here the use of photographic information to help the user to use the application. Firstly, to actually know the correct site because they may not have visited this site before. You'll see a photograph at the top. And secondly, to identify the poster that they are to remove and the one to replace it with. And the application also allows the user to photograph the final installation as a proof of delivery. So a graphical based application. Whereas the application on the right is an app that we built for a postal organisation. And their key requirement was speed of scanning. So the users are scanning parcels and then entering numerical data, the sizing of these boxes. And that application needs to be very accurate and very fast. The other thing is that the type of environment the worker is working in needs to be factored into the design. Is there a need for a rugged device? If the worker is working in grimy, dusty environments, or if they're expected to work out in the rain, then serious consideration needs to be given to that sort of device, particularly if it's a shared device and has barcode requirements for scanning. Does it need to be usable if they're wearing gloves? In the well pad location above, when Margot visited the site, we were told that it was that the sunlight needed to be taken into account with the application. It's extremely bright, extreme sunlight, 45-degree heat, where the screen effectively needs to be shaded by the person standing in front of the screen. So the application needed to be designed for high contrast and to operate in that sort of environment. Whereas the application on the right is a lift shaft where the user needs to operate perhaps for extended periods with no coverage. So what are some of the considerations for successfully delivering a project? So first of all, we can't overemphasize the need to start simple and really to focus on meeting the most important business objectives that meet 80% of the business benefit. It's tempting to extend the scope beyond some basic requirements. However, you can guarantee that that's going to delay the rollout of a project, even if the additional scope seems quite small. Starting small helps you to get a solution out into the field so you can start to get feedback and really make the solution work. Secondly, in order for the application to be successful in the field, you need good user adoption. That really means that end user champions need to be engaged all the way through the process, right from the requirements gathering stage right through to the training. When our business analysts commence a project, we perform site visits and ride-alongs so we can really get a good understanding of the workflow that these users use. The important thing here is we're trying to fit the application to fit the worker and the way they work, not the other way around, not to present them with an application where they actually need to change the way they work in order to accommodate an application. So if you don't have champions in the field, the issue is you could roll something out and get a very high rejection rate. So we need someone that can help us to support us through that process. The other thing is that no matter how well you do the design of the requirements right at the front end, you can guarantee that the system is going to need to be changed. So version 1 goes into the field, you're going to get user feedback. And unless that feedback is taken into account and rapidly deployed into the application, again, users can feel they're not being listened to. This is where things like the automation of forms and the ability to rapidly change them can really help to fit in with that feedback. So one of the things you need to think about is backwards compatibility. So in some circumstances, there can be hundreds or even thousands of users out in the field, particularly with contractors. Some of those users might be on devices that haven't been used for a while, so they haven't connected. And so you have a situation where users have updated to the latest version, and then a version 1 user comes back online. There's an expectation that that application should continue to work, particularly if there's jobs that are in progress. And the important thing here is really about avoiding big bang changes. Big bang changes are very difficult to coordinate, particularly spread across states and different organisations. So having backwards compatibility allows you to progressively roll out an application without causing interruption to your day-to-day workflow. So just to summarise the discussion today, we started looking at the requirements of the assets and the tasks needed to support those assets, the inspections, servicing and repairs required to perform those tasks, and their type and frequency. We then talked about the human factor, translating the asset tasks into logical groups that can be dispatched to the relevant work areas. And we also discussed the important design considerations, the implementation of workflow and forms, and considerations related to the screen design and also to the environment in which the workers are working. And finally, we talked about some of the key project considerations for a successful solution. We've really only scratched the surface today. And if anyone would like a one-on-one session to discuss anything in more detail, please feel free to contact myself or Margot, and we'll do our best to help you. At this point, we're happy to take any questions, and we'll take a look at the Q&A just to confirm if there's any requests. Okay, we've got a couple of questions here. So the first one is, hi Steve and Margot. In your experience, how have field technicians typically taken to the adoption of new technology, i.e. going from paper-based workflow to a mobile device like a PDA or phone? And how have some of your customers managed this change with their staff? Margot, do you want to cover this one, or do you want me to?
It's related to what you...
Yeah, look, I think, so I've had experience where this has worked really well. I've also had previous experience in a previous life where this has worked really badly. And I think the key is a point I've made earlier, and that is that there are champions in the business. The people that are actually using the application need to be engaged very early during the actual design phase. And that includes the selection of the devices. And it also means the user training, because the problem is if the word gets out that an application doesn't work particularly well, it may just end up not being used. So that was the first question. And then the second question is, can your company help develop project scope based on your experience and help build a business case and ROI? So yes, I mean, look, the important thing here is that when we engage with a client, we really need to get to the root of what the actual requirement is, the key business objectives. Sometimes we'll have customers that come to us and say, I need a solution, and I'll describe in detail what that solution is without really telling us why. And I think the important thing is that once we understand why a client wants to do something, the rest of it's actually pretty straightforward. Developing the scope and the business case. I'll give you an example. We had an engagement last year, and the customer wanted to automate timesheets. So basically they had 300 guys in the field carrying out construction work that were filling in paper timesheets. On a Friday, these would go to their supervisor. Supervisor would spend half the day actually checking the timesheets before passing it to someone who would enter that data into the back-end system. And the timesheets were always wrong. The guys were booking to the wrong projects. They were claiming expenses that they shouldn't have been claiming. They were claiming overtime. And so what we were able to do, once we understood what the key requirements were, we were able to build an application that really got the data right at the front end. And as you can see in that case, the ROI was all related to the time saving in entering the data, and also removing the requirement for administration staff to rekey that information into a system. So I don't think we have any other questions. So with that, I'd like to again thank GS1 for the opportunity for us to present today, and hopefully we're able to help some of you in the future. Thank you very much.